Hey, today we're going to disprove or prove the flat earth. What is it? How to get there? Let's find it. Here it is, the flat earth. Does it make sense? Does it not make sense? Probably makes no sense to you because you're looking at it wrong. Growing up, we're told all the wrong theories, and I'm here to set them straight.
Oh, hi. Welcome, science students, 2019. Today we're here to talk to you about something we're all familiar with. The unknowns in science and the air, therefore, within. Occasionally you'll come across a piece of erroneous data that will change your view on just about everything. Here I'd like to suggest to you the projection of a 3D surface onto a 2D surface, where the laws of gravity remain the same and perhaps give validity to the idea of the flat earth theorem.
Now, I'm going to explain to you why stars appear as circles and planets are round. LIGO. LIGO has gravitational waves that distort the universe, and they work in two parameters. You got your y-axis, you got your x-axis. Relate that to where we are. That's you. You can see that you get different angles. Now each of these angles has a distortion factor. The wavelength is distorted just enough that when it gets to us, these ones that are lower here, that look like discs, are distorted to look like circles when they get to us, as you see. Now, straight above us looks like a circle. That's when 12 o'clock, of course it's going to look like a circle because it's directly above us. A disc directly above you is going to look like a circle. You've seen that before, you've seen it again, you'll see it tomorrow.
You might be asking yourself, why does the water not all evaporate away all the time? Turns out we have perpetual clouds over top of this disk/bowl that we've discovered that we exist upon. Using thermodynamic properties and quantum tunneling effects, we recognize the aurora borealis.
Aurora borealis. At this time of year, at this time of day, in this part of the country, localized entirely within your kitchen. Yes.
Is all a magnetic field used to draw in the clouds to make sure that all evaporated water, the blue arrows, return from the red arrows to ensure that there is a constant continual flux of water up and down and that there's nothing outside of the system. As you chem students will know, this is an open system.
Brought to you by Flat Earth. Now, you might be wondering, if you see the sun has a path, well, by this equation, how's it set? How's it rise if the Earth is flat? True, we still have our disk. It spins around the central axis. It's actually disappearing and following a waveguide. This perturbed just a bit because it acts as a particle in a quantum well, where this is our energy and this is our potential. Now it can't escape that, but it is trapped within the waveguide. And since the waveguide is not consistent in its elevation, that's how we get our sun setting and rising. Just depends on where you are, what point the sun is. The moon, it actually has a repulsive vector coming off the end. Now you might think, why am I drawing this curve? Well, we also have to take into account the rotation of it. We did some experimentation. I'd like to show you. Confused? I am too. But I think we have an explanation. So if this is the Earth, this is us. And we have the rotation of the Earth. How does that work? We're not staying on. Throw that theory out. try this. It's a bolt current. That's not what we were talking about. But not a globe. So if we do the same experiment, look at that. It stayed in, except when I turn it upside down. But really, that just backs us up. And that's what I'd like to say on that. Circumnavigation. How does it work if the Earth is flat? So right here, all you need to know with a few words from my mouth. Now, say you start here, right there, South Africa. You come down, when you reach here, the curl vector, along with the Coriolis effect, redirects you. A little bit of magnetic field too, you know, all that good stuff. Curls you right back in, take another color. So if you're green, you actually take this path to circumnavigate. So really, there is no ice wall. That's a myth. Never was a thing at all. Just the sheer forces are you're unable to overcome them and leave the planet. Same way the water stays on, that's how we stay on. And back to you, Rachel.
Thanks, Donovan. And so finally, we'd like to confidently speak for everyone here in the physics department. The Earth is flat.
And thank you for coming to our TED Talk. I bet you're all wondering. That's against everything we stand for.